Hello there, good afternoon, or whatever time it is where you are watching this video right now. Welcome to this video where we're going to take a look at a problem that I've selected from an old Advanced Extension Award in Mathematics paper. So we're going back to 2005 here, and we're looking at the Advanced Extension Award in Mathematics paper from that year, and we're looking at question 3 from that paper. So I will, if I remember, include a link in the description to this video so you can download the past paper yourself, but I will put the problem up on the screen so that you can see it for yourself, so you know which question I'm talking about. Just so that you know, interesting bit of trivia, this was the Advanced Extension Award in Mathematics paper that I took right at the end of my A-level Maths and Further Maths course, and just before I went into university. So it's really interesting for me to have a look at some of these problems that I've not seen in some 20 years or so. Some of the problems I do remember. I have a memory of doing some of them in my actual exam. Others I've got absolutely no recollection of at all. So it's interesting for me to go back and see what kind of things I was getting up to in that exam. So anyway, here we go. Question 3. I've written it up on the board here, or the main details, but it's given that d by dx of u times the square root of x is equal to du by dx times d by dx of the square root of x. For 0 less than x is less than a half, where u is a function of x, and that u equals 4 when x equals 3/8. Find u in terms of x. Okay, so the Advanced Extension Award in Mathematics did concentrate mostly on, in fact entirely on, the kind of normal A-level maths content. So it didn't really include any further maths content. Okay, so we need to bear that in mind, that to solve this problem we probably only really need to use techniques that were, and still are generally speaking, on the just normal A-level maths course. So we're thinking about, because we're doing differentiation, product rule, quotient rule maybe, we're going to need to do a bit of integration. So we've got things like integration by substitution, integration by parts. We've also got separation of the variables, things like this. So I'm not saying that we need all of these techniques for this particular problem, but these are the kinds of techniques that we're going to be looking at solving it. And because this is a differential equation, there's only really a very limited range of techniques that you're really introduced to for solving differential equations at A-level. I'm not talking about further maths here, I'm just talking about the normal A-level maths. So that's kind of direct integration or separation of the variables. So this can give you some clues as to maybe where to look, what sort of techniques to look at. Don't worry, when it comes to solving a problem, don't worry if you don't have the solution in its entirety mapped out in your head before you even start. This is not it's not normal for this to happen anyway, really. If it's a challenging enough problem, it's something that you gradually work towards, because what scares a lot of people is the thought that they might try something and it doesn't work. Okay, what they want is the certainty that when they start their solution, they're going to be able to follow it straight through to the end, and that they know that it's going to work, as if it's some kind of failure when you try something out and it doesn't work. But this is not how problem solving works. Problem solving works along the lines of, you have ideas which may or may not work. You try to choose amongst those ideas which has the best chances of working, and you try it out, and either it works or it doesn't work. If it works, great. If it doesn't work, too bad. You try something else, but you've not done anything wrong by trying out different ideas. Okay, so when I was presented with this, I had no idea exactly. I'm talking about presented with it just recently, when I've looked at, I can't remember what I was thinking back then, but now when I saw this, I didn't know exactly how the solution was going to go, but I had ideas. Okay, and one of the ideas that I had was to, well, actually do the differentiation here and use product rule here to differentiate this thing. Okay, so you can do much worse than just being prepared to try out some various ideas. Even if you think that they're not going to work, sometimes they might actually nudge you in the right direction anyway. So let's go with that. Let's actually use the product rule on this thing here. So what do we get? We get this is going to be equal to du by dx times the square root of x plus u times d by dx of the square root of x, which of course is equal to du by dx times the square root of x plus u over 2 x to the power of minus a half. That's it. Okay, u over 2 x to the power of minus a half. Okay, so we know that this is equal to du by dx times, I've already differentiated that actually. It's a half x to the minus a half. So this is equal to du by dx times a half x to the minus a half. So at this stage, I'm just being prepared to read what's there and just do what seems right. Sometimes you just got to follow your nose and see where you end up. Okay. What I'm expecting though is separation of the variables. Okay. I don't see that there's really any other direction that this can go in. I could be wrong. And if that's the case, then we'll cross that bridge when we come to it. Okay. But sometimes rather than focusing on the things that could possibly go wrong and using those to try to talk yourself out of doing something that you need to do, sometimes just go ahead and do it, and you might find that all those things that you suspected were actually going to go wrong don't even happen. Okay, try to think of the things that can go right instead of the things that can go wrong. Of course, if you're naturally pessimistic like I am, that can be quite difficult to do sometimes, but that's what you've got to do. So what am I going to do now? Well, I don't like these x to the minus a halves in here. I'm going to multiply through by 2 root x, because then I'm going to get 2x du by dx plus u equals du by dx. Right, okay, so if you think about when you do, for example, implicit differentiation or something like that, sometimes you've got to rearrange to make dy by dx the subject, and you get dy by dx in terms of x and y. Okay, that's kind of what we're going to have to do here, I think. So let's try that out. Du by dx, so we get u equals du by dx minus 2x times du by dx, which of course equals du by dx times 1 minus 2x. So therefore we get du by dx is equal to u over 1 minus 2x. Perfect, because that's a separable differential equation. So at this point now, I'm expecting, this is just, it's almost like a bog standard A-level maths exam problem. Okay, I'm not expecting any real difficulties going forward. The advanced extension award stuff is here. It's over. It's done with now. Okay, we're on to just the normal math stuff. So really, I'm not expecting any real difficulties. But let's see what happens. So we've got du by dx equals u over 1 minus 2x. Get rid of that to clear a bit more space. So that means that 1 over u du by dx is equal to 1 over 1 minus 2x. So the natural logarithm of u, and I'm not going to worry about moduluses and things like that because it doesn't look like we need to worry about negative values and things like this. So I'm going to suppress the modulus symbols and this is going to be minus a half natural logarithm of 1 minus 2x, again suppressing the modulus symbols, plus c. Definitely don't need modulus here because 0 is less than x is less than a half, so this is always going to be positive anyway. Okay, so we've got this information here. So it's not a general solution that I want, it's a particular solution. Also, bear in mind that I've been instructed to find u in terms of x, which means that I'm going to have to rearrange this to make u the subject, okay? Which shouldn't be too difficult to do. But okay, let's plug these values in. So I get natural logarithm of 4 is equal to minus a half natural logarithm of 1 minus 2x is 1 minus 3 quarters. Oh, that's just a quarter, right? Quarter plus c. And that's looking good. The natural logarithm of 4 is, so what's a quarter to the minus a half? So the power of minus a half is 4 to the power of a half, which is 2. So that's natural logarithm of 2 plus c. This is twice the natural logarithm of 2. So c is equal to natural logarithm of 2. So this is looking good. Okay, so I can replace that with plus the natural logarithm of 2. We're done with all of this. Hopefully you're okay with your laws of logarithms and things like that. If you're not, get it sorted. Okay, so this is going to be natural logarithm of u is equal to natural logarithm of 1 over the square root of 1 minus 2x plus the natural logarithm of 2, which using natural laws of logarithms is going to be a natural logarithm of 2 over the square root of 1 minus 2x. By the way, I would recommend that you do this kind of simplification rather than just, what it might be tempting to do here is to just write this as u equals e to the minus a half natural logarithm of 1 minus 2x plus natural logarithm of 2 and just leave it at that. Okay, in my opinion, although this is technically right, you're clearly showing that you're lazy or that you don't understand, that there's something that you've not quite grasped, because this is not, generally speaking, how you would leave this expression. It can be simplified and it should be simplified. If you don't simplify it, it either means that you're showing that you don't know how to simplify it, or you're showing that you're lazy. Okay, neither of those is a good thing. Okay, and I can't say that you would definitely lose marks in this respect, but it's just not a good, it doesn't go in your favor. Okay, so be prepared to do a sufficient amount of simplification. And what I mean by a sufficient amount of simplification is, it might seem a bit subjective, but if you're used to simplifying expressions, if you're used to reading mathematics and you've made careful observations about what tends to happen in your textbook, what your teacher does and things like that, you will have probably picked up on how far you need to go with simplification. Okay, if you're not too sure, I mean, there's always a bit of grey area maybe, but there are some things that you should know that you definitely need to do. So to me, this is definitely something that I need to simplify, right? So we get u equals 2 over the square root of 1 minus 2x. And I think that is what is going to be expected of you, rather than this, right? So hopefully you can see why this would be preferable to this, even though, again, technically this might be correct. We're looking at this through the eyes of a mathematician here, okay? Not through the eyes of somebody who just wants a solution and it doesn't matter what the solution looks like. And to a mathematician, how something appears, its aesthetics are very important. This is a very important aspect of mathematics, the appearance, the aesthetic of something. And you might think, well, why? Why should I care about that? And the answer to that is because that's what mathematicians care about. Okay, so it's as simple as that, really. So u equals 2 over the square root of 1 minus 2x. At this stage, there's either two things that you can do. One, move on, because for all intents and purposes you finished, or you can check, right? I would check. I did check. And it turns out that this is right. But the first time that I went through this problem, this was, it took me 2 attempts to get this because I made a very slight error in my rearrangement. The first time that I went through, I made a silly error, but there was a stray minus sign, okay? And that, I followed it through, and I ended up with this solution. U equals, I think it was 8 the square root of 1 minus 2x. Okay? Well, I say solution, it's no such thing, but that's what I got anyway. Now, I checked this, and of course, it didn't work. So this is not a very pleasant thing to discover, that your solution doesn't actually work, that it's wrong. But at least it does give you the opportunity then to correct it, to find what exactly has gone wrong here and put it right. And it just turned out that it was a stray minus sign. So yes, I had to do a bit of work to follow that through to eventually arrive at what I know now to be the correct solution. And yes, I've checked this as well. But had I just left things at this, I would have been none the wiser. Okay? In my eagerness to move on to the next problem or whatever, I'm kind of throwing marks away unnecessarily. So you might think, well, in an exam, I don't have time to check. Yes, you do. Okay? In an exam, you have time to check. Should you check? That's up to you. You don't have to check. There's not going to be anybody telling you to check. But if I were in your shoes, I would check my answers as much as possible, especially on an exam that's kind of higher stakes. So if you're doing a step exam or an MAT or something like that, actually by including your check, because sometimes, especially with the MAT and sometimes with the step, if you're applying to university, depending on which university, the lecturers at that university may have access to your papers, may have direct access to what you've actually written, not just your grade, not just the grade that you got, but your actual script. So they can see what you've written. And sometimes much of their decision may be based on what you have written, as opposed to just the raw mark that you get on the test. Okay, so if you're showing things like you know how to check your work, this is all good, right? I'm not saying that that is definitely going to get you into the university that you want to get into, but you're showing that you understand what you're doing. Okay, you're just giving a little bit extra evidence to show that you understand what you're doing, and that you have good ideas, that you're going to be teachable, and you're potentially going to be successful as a mathematician at that university. Okay, so this is, as far as I'm aware, because I've checked it, and I've checked it as well as I can, just by differentiation, I've checked it and it works. Okay, so how would you differentiate that? Well, how would you check it? You would differentiate to find du by dx, and you'd also multiply it by the square root of x to calculate this derivative here. I'm not going to go through all of the details. I'm going to leave that for you to have a go at yourself, but definitely worth having a go at. And get into the habit of checking your work wherever possible. And by checking your work, I don't mean look at the mark scheme. I mean find ways for you yourself to check your own work. Okay, so that brings us to the end of this problem. If you do find these videos useful, by the way, please hit the subscribe button and hit the like button and show your support. I don't make any money from making these videos. I make them for free. I make them because I want to help you to do well in your exams, to get into the university that you want to get into. So I would really, it would be really great if you could show your support by hitting the subscribe button, hitting the like button, And if you know anybody else that you think would benefit from these videos, please share these videos with them. If there is anything that you would like to know, anything that you don't fully understand from this video, please leave a comment in the comments section and I'll get back to you. If you would like any one-to-one help with preparation for step exams, for your A-level maths exams, A-level further maths exams, MAT exams, things like this, please feel free to get in touch, because I've got a lot of experience working with A-level students on all these various aspects, helping them to get into university. And I'd love to help you as well reach your true potential and get into the university that you want to get into. So if you would like some extra help, get in touch. I'd love to have a discussion with you about what your needs are, what your requirements are, and how I can help you. And with that, I'm going to end this video. So thanks a lot for watching.